All right, well, thank you. So as I said, if you would like to have access to the slides, I just made them public and they should be available at that link. Someone shout if you try to go to that link and it doesn't work. But yeah, so that'll let you follow along, and later later today I'll going to be putting up all the content that I show. So what we're going to be talking about is, as in the title, making beautiful objects with Jupyter. So I see this as there being two fundamental kinds of beauty that Jupyter can really lend itself to. That is functional beauty and aesthetic beauty. These are, oh, I guess I don't have my speaker notes. Well, we're doing it live. So I see these as two aspects of the same sort of coin, though. Like fundamentally, if you are going to be creating good interactive computing environments, if you're going to be creating good things for people to be able to enjoy in the world, you're going to have access to both of these. Like functional beauty is necessary for it to work, and as Carol pointed out earlier today, if you don't have aesthetic beauty, you don't have the wonder. You don't have the things that are inspiring the dreams that move progress forward. So one of the examples that I think embodies that idea most clearly is text. So throughout the history of humanity, text has been both super functional and super aesthetic, and the challenges for both are inextricable. You have people, this is why we can talk, or at least hear from people hundreds of years ago, or at least read, and this is why you still have people struggling to get fonts to work today. These are challenges and awesome opportunities. So text is going to be sort of the larger focus of everything that I'm doing here, but there will be bits and pieces of other things thrown throughout. Okay, so the basic piece that we're going to start with is that we're representing objects in Python. So there's some background that I'm going to kind of assume that you all have, which is the idea that if you have a class in Python, you can set what are called dunder methods for the double underscore, dunder repr, which gives you a way to represent the object and control that, and dunder string, which is when you transform that object to a string, how does that happen? These can be different from each other, and really, we've always had a little bit of style in there because of ANSI escape strings. But we had no way to support richer types of media. And honestly, that's why we're here, is you wouldn't be in this talk if you didn't care about more than ANSI escape strings. We want richer things. That's why we are in the Jupyter IPython world. And oh, do we have those things. So the way that we have those sort of baked in is through the idea of media types. Now, you might have heard of MIME types before. That's the previous term. It comes from multi-purpose internet mail extensions. And I don't know about you, but I've not sent too many emails with attachments from Jupyter. It's mostly been all of the other amazing things that Jupyter can do. It makes much more sense to refer to them as media types. I'm going to do my best to do that. The APIs haven't changed, and so I still slip up. Very sorry about that. But all these are standard ways that we can refer to the different kinds of media that we're going to represent. So they're usually structured like there's a base type, so like text, image, and application, and then subtypes, possibly with a complete tree, and a suffix that gives you some more information about the structure of that subtype. So like text plain is plain text. An SVG plus XML image is SVG, which is XML formatted. vdom v1, which is a media type that we will be discussing plenty more of, is a JSON object. So we've got that. How are we using them inside Jupyter? So you all, I'm going to assume, know what cells are. So every cell, you may or may not know that they can have multiple outputs. And each one of those outputs can have multiple MIME types. And each media type, MIME type, it's going to be tricky, I'm sorry. Each media type can itself have data and metadata attached to it. But that metadata, it's stored per output, so you can only have one instance of that media type per output. So we're going to have all these, objects in our outputs. And front ends are going to choose amongst them which ones they're going to display. The general rule is they're going to display the richest one they possibly can. Usually that means text HTML, but sometimes you can get a bit more if you have extensions and whatnot. But some front ends just won't support some media types. For example, the classic notebook doesn't support the vdom media type that I had just mentioned. So this is my first diversion into a demo. So we'll see how well this works, because I didn't do this on a screen before. Great. And I will clear the output so that it will, oh, and of course I have a kernel error. That is definitely what I expected to happen right there. Now we're good. Come on, come on, come on, come on. Okay, yeah, we're good. Yeah, that happens to you enough and you know how to deal with it. But apparently we're not able to restart and clear output. Sorry, all. This is the problem of live demos. Okay, and I know that it's the IPython media types. So now we should have a regular old kernel, and yes, no outputs. So the first thing that we're going to do when we're doing this, and that's not going to be legible as it is, so time to do the zoom. So we're going to grab the IPython instance using the getIPython function, and then inside that, we're going to get a bunch of things called display formatters. Those are going to be, and those are stored in a key, a dictionary that's keyed by the different media types that we're going to be potentially using. So these are things like text plain, text HTML, text SVG XML, etc. And all of these are baked into IPython. It expects and knows how to deal with these. You can add more to it, but that's all that's there by default. And we're going to access those primarily through the use of repr methods. So these are ways for our custom classes that we're going to be able to specify how we are creating the representations for our objects. So in this case, we have our dunder repr, dunder string methods, but then we also have a repr HTML, a repr PNG, and a repr JPEG, which in theory means we should have a plain text, HTML, a PNG, and a JPEG media type when we output this. And they're all going to have slightly different content. So then when we actually create this hello object, oh, and this is one of the things that is not going to be available. We have the ability over here to choose between these different MIME types. So thank Matthias for having started this last year, and I picked it up. And so now we have the ability, so by auto, we're getting whatever would be there by default, so that's the richest one. Like I said, HTML is usually the richest. But if we have a PNG, then it's going to display a PNG. We're using matplotlib under the hood to do that. Same thing with JPEGs. So we're doing that right now by returning it. But we could also display it. So you may know about the display function. It's built into IPython. But note here that while we're displaying this thing, there's no output because it's a side effect. It's not actually being returned. So we have our text HTML, PNG, JPEG, just the same. OK, so what else can you do with display? Well, you can exclude you can include particular kinds of media types. So in this case, we're only including the image PNG. And in this case, we're going to be excluding everything but everything. We're going to be keeping only the JPEG and plain because we're excluding everything else. So in addition, we can consider it like I do the include below because what I'm going to show is a bit about the metadata setting. So all of your, like I mentioned, all of your outputs can have metadata attached to them, and this metadata can change how things are displayed. So for example, in this case, we're setting the width to 200 pixels on our two different ways of representing an image. And note that image PNG and image JPEG, they both produce the same approximate image. But now what I'm doing here is I'm setting the image PNG as the key to setting the width on this output. And so what will happen is that while we make the image PNG smaller, we don't make the image JPEG smaller. So if you ever need to apply metadata specifically to one media type, that's how you're going to do it. OK, last bit here is the idea of the repr MIME bundle. So far, this is one of those APIs whose name is going to be difficult to change. So far, we've been talking about a single function returning a single data type with some metadata. Now we're talking about one function returning the data for a bunch of media types and the metadata for a bunch of media types. So in this case, we're going to be returning some application vdom, as well as the images that we had before. And we're going to, in this one function, be setting the width of the PNG and the JPEG to be something different. We're still setting the HTML, and so that should be what displays by default. And now when we look at our little hello object, we see the same thing we've been seeing. But when we look at our JPEG, it's small. With the PNG, it's a little bit bigger. But then when we go and try to look at application vdom, it doesn't work. Why is this? Well, let's pop open Interact. So like I mentioned, vdom is not supported in the classic notebook, but it is supported inside the Interact interface as well as Jupyter Lab. And so this data is always in the, it's always available to the front ends. It's just a question of whether or not they can actually see it. All right, jumping back in to our presentation. So this is just a brief review of all the things I just talked about. I'm not going to go into it in too much detail other than to say one piece about repr MIME bundle is that it will take priority over any repr method that you set directly. Additionally, the display stuff, I covered all of that, but the one piece that I'm mentioning here, because I would feel remiss if I didn't, is there's also something very like repr MIME bundle called IPython.display that you can attach to your classes, and that will create displays as side effects. Unfortunately, this silences all of the other repr methods and makes them inaccessible, and you can't really easily overwrite that without deleting the method. So it's not generally a best practice, but there are certain cases, for example, when you need to make multiple display calls, that you want to do that. So we have in IPython a bunch of built-in display objects. They're pretty cool. I'm not going to talk about them because they take a while to go through, but you can, for most of them, you can pass in data or a URL or a file, and it's going to be able to figure out what it needs to do and display it in the appropriate form. One really neat one is an iframe that allows you to embed an HTML page in an iframe in your notebook, which is a really nice way to show off how generating HTML from notebooks would work. But that'll be in the repo if you want to play with it. Okay, so underlying all of this are some display messages. That is how this is being communicated over the wire. So there are two basic types that we've been looking at, display data and execute result. Execute result is what's happening when we're returning something. That's why we have that out there. Display data is occurring when we call display. It's happening as a side effect. There is a third type of display message, though, messages that are changing what we're displaying through this display mechanism that I've been talking about, and that's the update display message. And this happens because displays can be given a transient ID, that is an ID that won't be stored to the actual notebook data structure on disk, but it will be available in memory. So you can keep track of that ID, and then you have these messages that allow you to go back and change the content of that ID, of the display associated with that ID. So now jumping back out, we're going to try this. We're not going to go to the previously opened one. Display updates is our next one. So this is a fairly straightforward one. There are a couple APIs that allow you to have access to display IDs, and all of them already have their output. Really? I am so sorry, everyone. Well, if this doesn't work again, then such is life. Yeah, we're just... I should really figure out why that's happening. So now we'll have a live one. I'll just create a new server every time I need to do anything in the notebook. Okay, or not, you know, as the case may be. Okay, I'm going to quit this Chrome window, leave. This is my best chance Or I can just, so I'm going to go move on and hope that the next time I come up to this, because this actually is something that I can describe decently well. So there are 3 different APIs for actually handling an update display. You have a way of creating an ID on the fly by setting display ID equals true inside of a display call, and then that's going to give back a display handle, and then you can use that handle.update to apply to an object that will change the relevant content. We also have an update display function inside IPython.display. That is going to take in your object and the display ID. And then finally, you have the ability to use the standard display function to pass in an object along with your display ID and to tell it that update is true. If you don't put a semicolon at the end of that, it still returns a response. So it'll be a little bit messy. So that is the advised practice in those cases. So diving back in. So, so I'm going to now hopefully be able to demonstrate the ability of vdom and what you can do with it that you wouldn't be able to do in the classic notebook, that you can do in Interact and Jupyter Lab. So the key idea to vdom is that it's giving you a declarative layout in Python. So you might have heard of React. So it makes this distinction between an imperative and a declarative layout. Like an imperative idea is I'm going to go and I'm going to drive my car to get to the airport. Alternatively, I can just say I want to go to the airport car, and the car would drive me. It'd figure out all the details. All I need to do is declare what the state of the world should be. So that is sort of how a declarative layout works. And what this allows you to do is internally compute targeted updates so that you don't have to change everything like we're doing in the display cases. Additionally, this lends itself to like compositional functional paradigms because when you want to have this targeted updating, you can have these compositional pieces and you only want to update those individual pieces. And vdom is going to be returning us 2 different MIME types, media types, the application vdom and a text HTML. This means we can do some stuff in text HTML, but not that we can't do everything. And now, for the moment of truth, can I get this to work? Oh, that doesn't bode well. Oh, that really doesn't bode well. Oh, that's why it opened there. Okay. Please, vdom work. And do we have the ability to restart and clear? Yes, good. Sorry about that. We can see how we would do progress bars inside vdom. So the basic idea in vdom is we've got these standard HTML elements, div and style, for example. So one way that you would work with this, we just import div and style from vdom. And in this case, we're actually not creating a style element. What we're doing is we're creating a style attribute inside our div. And so when we run this, we're going to get back that text HTML because, again, as I'd mentioned, we're still not able to display the vdom object. But we can see something here because that text HTML has correctly interpreted all of those arguments to instead become the appropriate HTML. Alternatively, we could actually use a style object and pass in a CSS like selector and assign a class to our div. Now, class can't be used in the way that we used style above because class is a reserved keyword. So you have to actually, if you want to do something like this, create a dictionary and immediately unpack it. By the way, did I mention that I've been using Python 3.6 and Python 3 things everywhere? Just don't even try to do a lot of the stuff that I'm doing with, if you're not doing it in Python 3. It's a much better life anyway. You'll be happier. And this will have the same effect. We have got this simple little div. Okay, cool. So we have this idea. We can create a div. We can pass in the style. That's what our box here is. We're passing in width and background color because we're going to need to change those. The background color lets us have like the 2 bars that change together. And then we're going to create a div to wrap around the divs that we're going to generate. And because I have my little like toggle thing, I set the width to be 70%. So now we've defined those, and now we've got our the basis for our little progress bar. And so, as you can see, we now have a basic progress bar in the notebook using vdom. And all of that's happening with standard text HTML and updates, the display updates that I was just mentioning. So what more can we do? Well, we have the idea of a details and summary tags from HTML. So let's hide our progress. Let's have something that we can look at when we want it, but isn't going to be like interface all the time. So for example, that would look like this. We have a progress bar, and when we click on our little progress bar, then we get back our what the progress is. Of course, we did this statically here, so what happens when we try to actually run this? Well, every time we're clicking on the thing to expand it, it's being updated, so it's being overwritten, so we never actually get to see what the progress bar is until it's done, which is definitely the most useful progress bar ever. But this is where our beautiful functionality from Interact comes into play. So let's pop over there. So we're down here with our hidden progress bar and sharing the kernel. So we've got this, and we can just keep closing it and opening it, and that progress bar is not losing its state because all of those updates are being passed in, and it's holding the internal state so that it doesn't have to overwrite everything. It's only overwriting the parts that are actually changing the progress bar. If we want to make it a little bit fancier, here we've got some nested progress bars. We've got multiple things happening inside. We're going to run some code inside threads to be able to update those steps. And this will work inside of Interact. And I'll show you what happens inside of Jupyter in just a second. But yeah, so I know a lot of people have been asking for these kind of things in Jupyter interfaces for a while. It's actually one of the impetuses for vdom. We've got at least a way to approach this. But note that what I had to do here is create all of the objects and then pass through all of their values because we only have one display ID for the entire output. When we do go back to the, when we do go back to the classic notebook, and I try to run the same progress bar, not only can we not click and open this, it tells us that it's done. Like it's done executing, nothing more needs to be done because all of that's happening in threads. And eventually it will allow us to pop it open after that last one completes. And again, not just one of the best progress bars in the world, but 3. Those are our vdom. Oh, and that's what the updates updated was. Great. So we've got some challenges with vdom. I've just demonstrated some pretty cool things that people have been asking for a while. And like declarative layouts are pretty awesome. But, you know, Python syntax, it poses some challenges. I mentioned that we have these naming convention conflicts, but it's also standard in HTML when you're declaring your tags. You immediately put the attributes inside them after the declaration. But in this case, because they're keyword arguments, they have to come last because all the children that are not named are going to have to come before. Additionally, there are some things about dashes not being able to appear in expression names. It's also much easier to get this kind of reactive updating in the front end. It'd be nice if we could have that kind of selective update being passed along on the back end, and related to that, we don't have any way to compose these display IDs. We have one display ID per output. So these are all, the last few things, these are things that can improve. The syntax stuff, semantics, that's going to be trickier. But there is a beautiful future at some point where these things could be mixed and matched very nicely. So speaking of mixing and matching very nicely, the rest of this is going to be about integrating displays with external objects. And I just want to see, okay, I don't have that much more time. So far, I've been talking about functional beauty. Like all of these pieces that I've been doing, they focus on the way that we are using text and things like that to make stuff happen. Didn't really focus on aesthetics. I'd say that the idea that I was doing that is a bit of a stretch. So I really want to give us a tale of two beauties, and the way to do that is going to be XML, or rather highlighted XML, because, see, it's, That's the first one. We've got XML. It's an amazingly powerful structured data representation that is in plain text. SVGs are based off of this. RSS, which is how podcasts are distributed, is based off of this. XML itself, the JATS standard for journal articles is XML. So speaking of that, we're going to be using the all of PLOS library, which gives us access to all of the PLOS articles XML. And we're going to use pigments, and we're going to do that to get our XML samples. And we're going to use pigments, which is a generic syntax highlighter, inside a thing called DisplayXML, which is going to give us IPython compatible HTML highlighting that allows us to change the style and everything like that. Here's a tip: if you're going to be using pigments and you want to have different styles on the page, you should use unique classes at the top of it to be able to scope all of your styles so that they don't conflict with each other. I don't want to tell you how long it took for me to figure that one out. So hopefully we've got a functioning thing out of the gate. Okay, we don't have any outputs. That bodes somewhat well. And we've got, okay, so we're importing our display XML, we're importing all of PLOS, we're creating a corpus, which is just a collection of articles, and then we're going to get that first article. Title of that first article is Taking the Stem Cell Debate to the Public. That's its DOI. Maybe y'all should read it. I don't know. The key is that we're going to be able to do this with the XML. And so on the article, we can get the body from it and wrap it in this XML object. So now Pigments is happening under the hood, lexing it, and then applying these styles so that now what would have been something that looked like this looks like this. So the thing is that it sucks to have to write XML around all of your articles. It'd be much nicer if we could just have our article right there, and when we have the article, there's the XML displayed. So the way that we do that is we go get one of those display formatters, specifically the HTML formatter, because that's what we're outputting from the XML object, and we're saying, hey, assign it this function where we're going to create an XML object around the body of the article. And then we have to return, we can't just return that, we have to return the actual representation that we're going to pass back. And so that's why it's calling the repr HTML on there. And when we do this, and now we try to display an article, that article has the appropriate XML displays. Great, nice, simple, it worked. And now I'm having difficulty, there we go. Oh. So, I'm not going to go into this because I'm really running low on time. Oh, this is fun. Nope, that's not the one. What we want is updating XML. So we've already made it so that we can render our XML. Here, load well. Yes, good. Again, we're going to be creating our starter directory, we're getting our corpus, we're getting the first article from that, and then we're going to get our body. So we're just doing that so that we can have something to work with. And now we're going to create an empty display object. This is just so that we can have something to hang out around that part of the page. So now we've got nothing there. And if we were to go down here and display an ID on our empty display, what happens is it displays it down there, and it displays it up there, because they both have the same display ID. And one of the nice things that we have in the display XML object is direct integration with display IDs. So if we pass in as one of its initializations, not just the body of this article, but also the ID itself, we have the ability then to update its style in place. So note, we just changed this empty ID, we changed this one down here, but more importantly, now we have this rich XML thing that we got, that's our little XML document, and every time we rerun the style, it's changing under the hood to whatever it is that we want in all of the locations. So how that happens is fairly straightforward, actually. We're just checking if there is a display ID in the init, and then if it's there, we set it to self, and then we're going to update it, and then inside of a property and property setter, method, we're going to do the exact same thing. And the idea being that all of the properties that we're going to say are selectively being updated, that is, reactive Python objects, well, those are going to be the ones that we're paying attention to when trying to make this happen. Oh, it starts now. Oh, right. You'll have to ask me questions afterwards because there's so much stuff to show you. So XML, it's beautiful on the inside. But I was showing this mixture thing, but now I just need to like lean into this aesthetic stuff because, it's fun. So yeah, we're going from what looks like this to that. I don't know if that's meaningful to you, but it's all the punctuation that was in there aside from the angle brackets. So this, what I'm going to now show, is inspired by, I don't know how to say his name, Nicolas Raju. Between the words. So that is all of the punctuation from Lewis Carroll's Alice's Adventures in Wonderland, arranged on an Archimedean spiral. And one of the really nice things about Jupyter is that you can do this, and you can do it live. So yes, spiraling out of control. Yeah. Unfortunately, this is going to take a bit of time. So the slowest thing in here, the one thing that I had wanted to actually have run before I started was this, because it takes a little while, because what's happening under the hood is SymPy is figuring out the tangent points to a polar set of polar coordinates at a specific angle repeatedly all the way around, generating all of the the quadratic Bezier curves so that we're able to actually represent what's happening here as an Archimedean spiral. And that's necessary if we're then going to apply the SVG styling that is going to allow us to take all of the punctuation. Oh, we're getting these articles from the corpus again. Good, our spiral is done. Articles from the corpus again, and now we're going to display them. So that this is all of the articles. So let's see, what is the article that we just dealt with? Corpus 1. So previously, that was the Alice in Wonderland that I had shown you. This is EGF signal propagation during C. elegans volval development mediated by ROM1 rhomboid. Wow, Lewis Carroll has nothing on them. So that's one example, but hey, why don't we do a bit more fun stuff? So let's color code all the connectors. So connectors are going to be green, wrappers are going to be blue, I think it is, and punctuation is going to be red. And there we go. It's the same one. Let's try a different one. 9. Awesome. So we've got the ability to do that. Can we do more? So we've got this corpus. It's a bunch of different articles. So maybe for the corpus, when we want to make it pretty, we'd have a way to do more than just have that plain text representation. We could randomly generate one of these objects. And each time should be a little bit different. How are we doing? Yeah, okay. But I bet we can do better. So what's happening here, it's the same function under the hood, but I'll see if you can catch the difference. But I'm going to mention that previously it was an SVG display output. And now we've got, they don't all line up. But yeah, so again, this is all vdom under the hood that is enabling this. I'm happy to show you the code. But yeah, that just all happened now. That person sells posters of this, and they're really nice and better kerned and all of that kind of stuff. But the fact that you can get this far in a few minutes is, that's a lie. It took a lot longer than a few minutes. But once it's done, it's done. So yeah, and with that, I think I had a random slide at the end instead of a thank you slide. So instead of thank you, I guess I'll say beautiful on the inside. Do we have time for any questions, or are we completely off? One? Okay. Anyone have one question? What? Oh yeah, that'll happen. I'll sit down and do. I can do it while I'm standing here instead of answering a question.
Is there a way to determine what environment you're in so that you would set a fallback if
So you don't, ideally you don't need to do that, because in all the cases where you could have the text HTML functionality, it works. The problem is you can't have reactive updates without something like React, and you can't have React in the notebook without a gigantic refactor. That's not going to happen unless you want to do it, in which case that would be awesome. And then vdom would be in the notebook. So unless there's any other quick question, I think that is it. You can get a hold of me at mpacer at netflix.com. I'm happy to answer any questions. I'm going to be at the Netflix booth, and I hope you all have a beautiful night.